afternoon, everyone. Today, we want to discuss the likely question that you are going to see in SSC WAEC 2025. And the subject we want to deal with today is physics practical. Now, physics practical is a compulsory subject that science students must do. And we want to do a 5 series video that that we will try to treat the questions that will likely come out in 2025 WAEC. Now, but today's video is the first series, so this video is going to cover how to plot graph, all you need to know about graph plotting, because physics practical is a kind of a subject, a paper that has 3 questions, and which you are the candidate is expected to answer 2 questions out of it. And each of the question you are going to plot graph of those questions, because you are going to carry out experiment in the laboratory. And when you are carrying out experiment in the laboratory, you are expected to use graph to represent the result of your experiment. So today we want to deal with all the tricks and tips on how to plot a graph, the rules you must obey while plotting graph, the rules you must obey when you are making the tables, and so on and so forth. Now let's jump right in. Now, in your exam, they will tell you to make some readings, to create some readings in the experiment. Now, the readings is usually 5 readings, sometimes it can be 6. Now, all those readings that you take will be uh, will be will be represented on a graph. Now, let's assume that you have a graph, and the graph looks like this. Now, maybe this is your y-axis, we all know that, and this is our x-axis. Now, if they say that plot a graph of A against B, then that means A will be on the vertical axis and B will be on the horizontal axis. That's what they mean by plot a graph of A against B. A is going to be on vertical axis and B is going to be on the horizontal axis. Now, when you are plotting your graph, you'll be making points of those your reading. Now you are going to make points. Let's assume that the 5 points that I've created are like this, and I want to plot my graph. The best way is that you look for, out of those 5 readings that you just plotted, you look for the 3 aligned points to make your straight line graph, because it is always demanded that you plot a straight line graph. So you check the 3 that is aligned. Now, from what I see here, 3 here are aligned. So I can easily go for this one and align it. Don't mind me. And align it. So these are the 3 that are aligned. Now, when you locate the 3 aligned points, there is another rule that you need to follow. The remaining points that are not aligned, some must be on one side of the graph, and the other must also be on the other side of the graph. Look at this. There are 2 points here. There are 1. So this one is a perfect graph. Make sure that the remaining point does not stay on one side of the graph. Ensure that some are on the left and some are on the right side of the graph you just plotted. That's the first rule while plotting a graph. Now, I will use one example to plot some graph with you, and you are going to see how it is being done. Now, let's take some example. Now this is an example of a table that I just brought up. Now if you look at the first table, the first one is representing current. I is current and the unit is always ampere. So when you are making your table, you write the symbol for that quantity and you now write the unit, you put it in bracket. Now the second column there is a voltage, that's V. You now put your unit of voltage to be volt. Now look at this one, I raised to power minus 1. I raised to power minus 1 means you are going to say 1 over I. You know that that's what is done in the law of indices, you know that. So I raised to power 1 is 1 over I. Now like this one now, I says 0.3. So that 1 over I raised to power minus 1 is going to be 1 over 0.3, which is what? 3.33. This one is 0.5. I raised to power minus 1 is going to be 1 over 0.5, which is what? 2.0. Now another rule that you need to follow is that all quantities, all physical quantities in physics has their own decimal places that you use when you are making your tables. Now it is very simple to do, and how you will go about it. Now if it is all electrical quantities, rather, then current is always 2 decimal place, voltage is always 2 decimal place, and resistance is also always 2 decimal place. Now some other quantities like length is also expressed in 2 decimal place, but some other quantities like mass can be called to talk about mass. Mass is 1 decimal place, time is 1 decimal place, angle is 1 decimal place. Then angle is 1 decimal place. Then any value that you calculate, that you have to use calculator to obtain it, is always in 3 decimal place. Like this I raised to power minus 1 that I just did, you will see that it is in 3 decimal place. So every calculated value has to be in 3 decimal place. Now let's see how we can plot this graph that we are seeing here, and let's see how you can plot it. So if you plot it, you now see how graph is being plotted. Now we are going to answer some questions under it, determine the slope and the likes. So let's jump right in. Now they say that we should plot a graph of I against I raised to power minus 1, and they say that we should determine the slope of the graph. How do we go about it? We are going to use our ruler to plot our graph. Wow, my hand is shaking. Why? They say that we should plot a graph of V against I raised to power minus 1. It is very simple to do. Now, this is our V. We put it on the vertical axis. And this is our I raised to power minus 1. We put it on the horizontal axis. Now, how do we go about it? We are going to select our scale. Now, the lowest is 0.9 and the highest is 1.7. Now what do we do next? We are going to find we are going to make our scale 0.2, 0.4, 0.6, 0.8, 1.10, 1.2, 1.4, 1.6, then 1.8. Don't mind us. Let's shift this one upward. This place will be what? 1.6, and this place will be what? 1.8. Now this one will now be V into V. Now this one, I think we are okay. 0.5, 1, 1.52, 2.53, 3.5, and so on like that. So we are okay with this. Now the scale you are going to write the title of the graph first. say a graph of V against I raised to power minus 1. That's what you write first on the top. Now the next thing to do is to start plotting the graphs one after the other. Now the first one is 1.7, whereas this one is 3.3. So let's go for 1.7. 1.7 should be around here, and 3.3 should be around here. So look at the place where it joins. So let's go. So we are going to have it here. That's our point. Now the next point is 1.5 and 2. So 1.5 here, 1.5 on the y-axis, this 1.5. Now 2. Let's go and let's see where it meets this place. Now the next one is 1.3 and 1.4 because that's 1 dp. So let's go 1.3 and 1.4. Now let's go 1.3 and 1.4, 1.2, 1.3. Now 1.4 should be around here. So it's going to be around here. Now the next one is 1.1 and 1.1. Now let's look for 1.1 here and 1.1 somewhere here. So the next thing to do is to look for what? 0.9 and 0.9. So let's go for 0.9 here and the 0.9 here. So it's going to be somewhere here. Now we've got 3 points. We've got 5 points now. Now how do we go about it? Let's look for the points that are aligned together. Now these 3 are aligned. I think they are aligned, yes. So these 3 are aligned, but if we do the 3, there's a possibility. They say that we should plot a graph of a V against I raised to power minus 1. It is very simple to do. Now this is our V. We put it on the vertical axis, and this is our I raised to power minus 1. We put it on the horizontal axis. Now how do we go about it? We are going to select our scale. Now the lowest is 0.9 and the highest is 1.7. Now what do we do next? We are going to find we are going to make our scale 0.2, 0.4, 0.6, 0.8, 1.10, 1.2, 1.4, 1.6, then 1.8. Don't mind us. Let's shift this one upward. This place will be what? 1.6, and this place will be what? 1.8. Now this one will now be V into V. Now this one, I think we are okay. 0.5, 1, 1.5, 2, 2.53, 3.5, and so on like that. So we are okay with this. Now the scale you are going to write the title of the graph first. You say a graph of V against I raised to power minus 1. That's what you write first on the top. Now the next thing to do is to start plotting the graphs one after the other. Now the first one is 1.7, whereas this one is 3.3. So let's go for 1.7. 1.7 should be around here, and 3.3 should be around here. So look at the place where it joins. So let's go. So we are going to have it here. That's our point. Now the next point is 1.5 and 2. So 1.5 here, 1.5 on the y-axis, this 1.5. Now 2. Let's go and let's see where it meets this place. Now the next one is 1.3 and 1.4 because that's 1 dp. So let's go 1.3 and 1.4. Now let's go. 1.3 and 1.4, 1.2, 1.3. Now 1.4 should be around here. So it's going to be around here. Now the next one is 1.1 and 1.1. Now let's look for 1.1 here and 1.1. Yes, it seems what I am writing here is not that clear. No problem. Now look at the slope. Let me do a recap. After plotting the line, you make a triangle of this nature like this, like a right angle triangle. Now after doing that, get the value of the point that is here. Hmm? Now when I get this one is what 1.5 minus. Now get the value of the point that is here and trace it to this place 0.6. Now over get the value of the point that is here down, that's what 2.0 minus the point that is here, it should be 0.35. Now the answer is going to be what? 0.9 over 1.65. Now let's get a calculator. The answer is 0.5454. So that means it should be 0.55. Now after we have done this, it is very simple. The next thing you do is that you are going to look for the point and the unit of the value here. The unit here is a volt, and this one, the unit here is a raised to power minus 1. So you now say v over a raised to power minus 1. So you have to be conscious of the unit that they give here. When you have calculated your slope, you use the unit here divided by the unit here, not the quantity. So the unit here divided by the unit here, so it will be the unit of your slope. Then there is also another question that they usually ask, and the question is intercept, the place where this your initial graph cuts the y-axis. This intercept here cut the graph at 0.4, so you can say intercept is equal to 0.4. This time around it has to be on the vertical axis, so v. Then sometimes it can cut the horizontal axis. If it cuts the horizontal axis, especially if it is a negative graph, just like the one I explained yesterday and now the other time. So if it's a negative graph like this, if it goes like this, then after calculating your slope, you might get the intercept on the y-axis. And I told you that after, if you have calculated the slope the way I did it, just like this over this. Now if you have calculated your slope, then you put negative there because this is a negative slope. If graph goes like this, it's called a negative slope. Stay tuned for the next video that will now cover the real practical. I told you earlier that the first video is going to solve problems that are related to graph plotting, table, how to make a table, how to tabulate readings, and the rules that are associated with all the units. That's what this first video is all about. So the next video now will now take you to the laboratory where we do the real practical that are likely to be and that you are likely to expect in this upcoming WAEC in a couple of days. So stay tuned, subscribe to my channel and share it to your friends. So keep on, so that by the time you subscribe and click the notification bell, when I post a new video concerning WAEC 2025, then you are going to be able to see it easily. Thank you so much.